Thank you very much for attending this evening. I'm Charles Dunn. I work during the daytime as a consulting engineer with RPS, but I represent CIBC, Building Services Engineers, on NSAI TC2, where we have a good team of people working on producing primarily the national rules for electrical installations. I googled, in order to prepare this presentation, I googled ET101, which is the national rules for electrical installations, and I'm sure probably a lot of people in the audience have done that at some stage as well, and I've come up with this document, the Cosmic Instruction Manual. Well, I can assure you that that's nothing to do with the subject that we're going to speak about this evening, but it did cross my mind when I saw it, that in fact our industry as well is full of acronyms. So I suppose let's try to explain some of the acronyms that are there. I've got used to them over a period of time, but starting at the top, NSAI, National Standards Authority of Ireland, they've been producing Irish standards for many years. We are a technical committee too, because NSAI in fact don't write the standards. They rely on industry experts to come volunteer, sit around the table, put together the standards, and then NSAI effectively is the secretariat and the administration part of publishing those documents and making them available to the public. ETCI, of course, is the Electrotechnical Council of Ireland. Apologies.
You don't need to keep the mic that close, it's public language.
Okay, apologies for that. I'm learning how to use mics. I'll go on to news reading next. The Electrotechnical Council of Ireland used to previously produce the national rules, and now that function has been taken over by NSAI. And I suppose a key piece of legislation for us is the Electricity Regulation Act 1999, which empowers a lot of what we're at in relation to the national rules for electrical installations. The Electricity Regulation Act empowers the Commission for Energy Regulation, CER, as it was at that time, and it gives them certain obligations and regulations, and that includes and incorporates the national rules for electrical installations. So CER used to look after electricity, and then it started to look after gas as well, and now of course it has been given the job of looking after water. So it has changed its name to CRU, which is the Commission for Regulation of Utilities. And they are a key part of the legislation and the control of the electrical industry in Ireland. So that's CER there, looking at the Electricity Regulation Act. One of the key tasks that they've given CRU is to regulate the activities of electrical contractors with respect to safety. That's an important note for all of us to remember when we're considering the national rules for electrical installations, because they're primarily set out to look after the safety of people, to prevent electric shock. They don't talk so much about continuity of service or quantities of outlets. Their primary function is to look at the safety of the electrical installation. As part of its obligations under the Electricity Regulation Act, CRU was required to set up a register of electrical contractors to implement some standards in the electrical contracting industry. And that they have done through RECI, which is also badged as Safe Electric. The second job they were asked to do is to set up a safety inspectorate, which is Safe Electric RECI. So RECI have the job of going out and examining installations on a random basis across the country that have been installed by registered electrical contractors. That includes installations that you will have specified and will have been involved in the installation of. RECI still have a right to go out there and have a look at those, and the installations that you have specified or worked upon are required in law to comply with the national rules for electrical installations. If they don't, there will be a certification problem on site, and effectively we're in breach of the Electricity Act, the Electricity Regulation Act. CRU was also required under the legislation to have a set of rules. Now, it was easy at that stage. They simply turned to ETCI, who had created the original rules, ET101, and they badged that as the set of rules. That set of rules was previously published by ETCI, and the publication and the management of that has now been taken over by NSAI. So that, I suppose, brings us to where we are now today with NSAI in relation to the rules for electrical installations. At the moment, NSAI publishes and distributes ET101, but when the new set of regulations comes out, they will be given an Irish standard number, IS10101. We worked with NSAI on Technical Committee 2 to try to hold on to the number 101, because that was important to the electrical industry, and unfortunately we weren't able to get 101, we had to have the 10101, so it sounds a bit like a digital tail gone wrong, but that's the purpose and the reasoning behind the number. Technical Committee 2 is made up of industry representatives, and they're all volunteers. Nobody is paid for doing the work. NSAI provides the administration work, the front end, but the volunteers come from the Electrical Manufacturers and Distributors Association, from designers, consultants, from the contracting industry themselves, from larger property organisations, a broad range right across the electrical industry. And it is the objective of TC2 to try to make sure that the membership of the committee, which is involved in writing the Irish standards, that it is representative of the industry all the time. That is something that we focus on and try to keep an eye on all the time. In terms of writing national standards, obviously NSAI is used to writing Irish standards. They've been doing it for years on end. So in terms of the design industry over here, we've been using Irish standards for years, and particularly in the building side of it, we will have been using domestic gas installation standards, emergency lighting, fire alarm standards. So having IS10101 fall into the NSAI stable isn't anything strange or new. It's something we will have been used to before. With one slight difference. Under the Electricity Regulation Act, the IS10101 will actually have a legal standing, and you will be required to comply it, whereas the other standards may be guidelines. And for instance, in the fire alarm or the emergency lighting standards, designers are allowed to risk assess or to deviate slightly, provided they document that in their certification. Under the Electricity Regulation Act, IS10101 is a legal requirement, and compliance with that cannot be avoided. So this is a quick look back at previous editions of ET101. ET101 is on its 4th edition, and I did look back and I was able to come up with a copy of the 3rd edition. I wasn't able to come up with any copies before that, and if there's anyone in the audience here who is old enough to have a copy of before that, maybe they want to put their hand up or maybe they don't. But we, thanks guys. But we're on the 4th edition, and it's interesting to see that in the UK, there are rules for electrical installations, BS 7671. Number one, it has been a British standard for many years. We're only moving into being an Irish standard now. But also, the British standard is actually on its 18th edition, and we're only on our 4th edition. You can clearly see as well when we're on our 4th edition, it was published in 2008, and it has had several amendments since then. But being 2008, we're over 10 years old, and an awful lot has changed in the electrical industry since then. And in terms of international standards, a lot has changed. So having a rewrite is not just important, I suppose, it's pretty urgent at this stage. I think the original objective may have been to try to get this out in 2018. We've missed that date, so the 2019 date or 2020 date is kind of very important at this stage. NSAI is Ireland's representative on CENELEC and IEC. These are the two international bodies that create the standards. Ireland has, since ETCI days, had a seat at both of these bodies. We have an entitlement to travel to their meetings, but also to comment on their documents, to add to the standards before they become harmonised documents across Europe. And as part of our, I suppose, our responsibility, we have the entitlement to sit at the table and also to get involved in the decision-making process. But then the responsibility that we have after that is to adopt the standards once they have become a harmonised document right across Europe. So I suppose it's important to see that we have a say in how the harmonised documents are created in the first instance. If we don't like what's going into the harmonised document, any country in Europe can look for what they call a special national condition, which is an exemption. If there's a particular clause that you find your particular country shouldn't implement, then you can look for a special national exemption and a special national condition, and that exemption will be included in the harmonised document so that you won't actually have to implement that particular section. However, once they become a harmonised document and all those special national conditions are listed in them, Ireland is then obliged to adopt them into their national standards. In order to proceed with this type of work, what we do is we follow the standards that are being produced by IEC and by CENELEC, and in particular, we follow Committee IEC TC64, which looks after the national rules for electrical installations right across Europe. They produce a set of harmonised documents focused particularly on that. And the job of TC2 is to mirror IEC TC64 and effectively make sure that we're following European standards that are produced by them. So this is a particularly busy slide. You don't have to read it all. Oh, whoops, sorry about that. I didn't read it all. No, I suppose this is the key objectives of IEC TC64. And just to outline, I've highlighted some of the stuff they're talking about there. Amongst their key objectives are the protection against electric shock. So we can see again here, it's not about continuity of service, it's not about quantity of outlets, it's all about protection against electric shock, it's all about the safety. Its voltages up to 1 kV, not beyond. In Ireland we have a committee TC3 under NSAI and they look after beyond that, but their guidebook is a different guidebook, it's not empowered by the same legislation. So IS10101, which is empowered by the Electricity Regulation Act, only deals up to 1 kV. That's of big interest to many designers in Ireland that are now working on developments that take power at 10 kV, where the client owns their own transformer. So many of our big data centres and everything like that, the MV side of the installation is not subject to the Electricity Regulation Act and is not part of IS 10101. Further down in that, we look again, their objectives include safety requirements again, and also they make the big point that they do not cover individual items of electrical equipment. So this is a key point, and it's a question that regularly comes up from the public to either to RECCE, to TC2, is items of equipment, electrical equipment that people consider might be dangerous or should have a standard written about them. The wiring rules IS 10101 go up as far as the isolator or the socket. They don't go beyond that. So anything that's connected after that is not part of the verification process, part of the IS 101 standardization process, and is not checked effectively by RECCE. But that's okay, because as designers, you won't know what's going to be connected invariably. You'll go up as far as the isolator for a factory premises or for industrial and office premises. You leave the sockets and the isolators there, and then the client will do the fit out themselves. So what the client fits out is not part of your brief, and consequently doesn't fall under IS 10101. The primary objective of our national rules for electrical installations, then following on from our brief from TC64 and from IEC, is the protection against electric shock and voltage up to 1 kV only. It's safety again, and it doesn't cover other items of electrical equipment. The remit ends at the socket or the isolator. An interesting clause that I had hoped might be in our national regulations, but unfortunately it isn't, is in BS 7671 they have a clause under 120.3 which allows the designer to suggest an alternative specification. This is a question that crosses our desk sometimes in TC2 as well. Unfortunately, that clause does not apply in IS 10101. So under the fire alarm or the emergency lighting codes or other standards, the designer is allowed to risk assess something and to take a particular view and to vary using their specification to vary the rules. That's not permitted under IS 10101, and if there's an inspection on site of the electrical installation by RECCE, if it doesn't comply IS 10101, it's simply a failure. The designer does not have the power to deviate from IS 10101. These are just sample harmonised documents that come down from Europe. So what TC2 receives by email and online, we log on to the IC and the CENELEC websites, where we receive on a continuing basis harmonised documents or documents that are what they call committee drafts, CDs, or committee draft for vote, and we get to vote on the documents as they go through, as everybody else in Europe, all the other countries that are part of the system. Through our vote there, we can seek, as I say, a special national condition if we find that there's a particular item in there that would be negative or not helpful towards the Irish industry. But generally, our objective is to adapt the regulations as they come in. We adopt them, but we can adapt them, and in some cases, areas such as bathrooms or whatever like that, we may have particular rules, Britain does as well, where we may have additional safety requirements in the Irish rules that don't exist in the harmonised documents or in the European rules. So we are allowed under IEC and CENELEC rules to add additional safety requirements, but not to reduce the level of safety that's available to everybody else in Europe. This one slipped up slightly again. So we're back, as I say, at the 4th edition, 2008. It's empowered by CRU under the Electricity Regulation Act, but also it's interesting to see that the Building Regulations Part B refers to the National Rules for Electrical Installations, refers to ET 101, which will, in future, just by transfer of law, it will be transferred to everywhere it says ET 101 will now refer IS 10101. So the new standard will pick up exactly where ET 101 was. It'll effectively become the 5th edition of the National Rules for Electrical Installations. We'd looked at that before, that the UK regulations are already a British standard. One of the other interesting notes about that is the fact that it's called National Rules for Electrical Installations. This is something that comes up in relation to queries as well. It's not what you would refer to as the wiring rules, although people commonly do refer to it as the wiring rules, but it's the whole electrical installation, and that includes the cable containment, everything to do with it, the switchgear. So it's not just the wire in there, although sometimes people do refer to it as the wiring rules. It's actually the national rules for the whole electrical installation. I dropped in a note there, a quick note on controlled works and restricted works, and this is just something that designers mightn't have seen or picked up on before. CRU, who have power under the Electricity Regulation Act, have issued a definition of what they refer to as being controlled works, and they primarily list, say, adding additional circuits, changing a distribution board, or a brand new installation. Those controlled works, if they are undertaken by a registered electrical contractor, must be certified. They must have a completion certificate done for them afterwards. Probably as part of your specifications, if you're designing, you will actually ask the contractor to certify afterwards that he has installed in compliance with the wiring regulations. You might or might not do that. But in fact, under law, once any of those actions is undertaken by a registered contractor, then that registered contractor must complete a certificate in accordance with the rules and must submit that directly. Interestingly, restricted works covers the same definition, it's the same items. It's adding an additional circuit, changing a distribution board, or making a brand new installation. But restricted works must be installed only by a registered electrical contractor. Restricted works refer to domestic installations. And in domestic installations, the work must only be undertaken by a registered electrical contractor, whereas the controlled works can happen on an industrial site. If you have a contractor who's not registered, he's not legally obliged, but you probably wouldn't be specifying or allowing a non-registered contractor to work on your sites anyway. I only mention that because it's a piece of legislation there that issued by crew, guidance issued by crew, that we probably don't pick up on that much as designers. Did we skip one there? No, that's controlled works. And what's new? So finally we get to slide 10, and we're beginning to see at least one thing that's new in the rules and regulations. The parts that we previously referred to in ET101 are now going to be referred to as chapters. This really doesn't affect the way the document works at all. It's just a different, and the change in referencing is to match the harmonised documents, which are right across Europe. So we've had to lose our parts and refer to them as chapters instead. The scope hasn't changed either, and the scope remains up as far as the isolator or plug or socket, but not beyond that. Definitions. The definitions have now been lumped all up the front end of the book to make it easier to read, up the front end of the standard. Previously, the definitions were spread throughout the sections, right across the book, and that may have led in some places, we feared when we were reviewing the document, to possibly different definitions for the same thing. What's an isolator, or what is a domestic premises? What's a public premises? So it was clearer and easier if we lumped all the documents up the front end and just had one definition for any of the particular items up the front end. It saved duplication and contradiction. And also, the new standard now borrows heavily from the International Electrotechnical Standard IEC 650. It's the International Electrotechnical Vocabulary. So we have tried to standardize the definitions that we have in IS101 with what's in already established international vocabulary definitions. Right, something else that is new, residual current devices. These will now be required to be installed on lighting circuits in all domestic premises. You'll be aware that they're already required on socket circuits. There was a lot of discussion about this at our task force level. It has come down from the harmonised documents in Europe. RCDs do provide additional protection, and therefore the reasons for leaving them out originally, when RCDs were first introduced years ago, the reasons for leaving them out of ET101 in 2008 was RCDs had a habit of tripping accidentally, and that could leave a part of a premises without lighting, which might lead to a more severe danger than the original earth faults that we're trying to interrupt. However, it has now been decided that RCDs have come of age. They're far more reliable than they were before. And also looking back at statistics, because the TC2 group relies on input from a lot of sides of the industry, including the Health and Safety Association. Looking back at the statistics, it is seen that if somebody goes to work on a light fitting in a house on a lighting circuit, it is most likely an unqualified person. They probably don't have the tools that they should have, whereas somebody working in a commercial installation is probably a registered contractor and is probably has the right tools and will probably find a fault before they put their hand on the device. So for that reason, the RCDs have been adopted into the rules as being required in domestic premises, but not in commercial premises. It will make your board a little bit bigger. But the price of RCDs now has come down, that it shouldn't have a significant effect on the installations. Arc fault detection devices are something new that's coming down the line to all of us. These are now recommended for circuits in particular installations. Arc fault detection devices look at where there may be a flashing or an arcing in the installation that previously any of our detection devices wouldn't have picked up. If it wasn't a fault to earth, then our RCD wouldn't have picked it up, and if it wasn't an overcurrent, the overcurrent device wouldn't have tripped. So we could be pulling, even up to 1 or 2 amps across an arc fault that might be flashing away and will eventually lead potentially to a fire. Arc fault detection devices have been in use in the States for quite a few years. The manufacturers' representatives in Ireland have been able to tell us that they are widely available. There doesn't seem to be a reason why we would seek a derogation from the harmonised documents across Europe, and therefore the recommendation will be included in IS10101. It's recommended for particular locations, not everywhere. The arc fault device, we're just showing with the graph on the left-hand side there, looks at the sine wave that you should be seeing across it, but it looks at the variation in that sine wave that would arise if arcing was occurring outside in the circuit somewhere. The arc fault device will slot into your distribution board much the same as an RCD would. And over a period of time, we'll probably see them in more and more installations, and they'll be more commonplace. At the moment, they're only recommended for certain locations, so they're not mandatory. So if you have designed them in or specified them into your installations, that's grand. But if you haven't put them in there, RECCE won't be looking for them on an inspection as being a fault. It's only a recommendation. What else is new? Selection of equipment. Electromagnetic compatibility has been an issue right across Europe, and there is a requirement in the harmonised documents that the designers or a person responsible will sign off on the installation to say that there's nothing in there that upsets the EMC directive. We're halfway there. I put that slide in more from me than I did for you guys. And we've managed to get to this part in the talk without mentioning a backstop agreement at all. This is a big change. Cables, prior to the issuing of the new national rules, we had received representations from several government departments trying to improve the standard, the fire rating of cables throughout all buildings. And ironically, this discussion has been going on for quite a period of time. We have been helped in this by TC14, which is the NSAI committee that deals specifically with cables. They're specialists in the field. So there was a lot of debate about this. It went around many, many times, and we got reminders from several of the departments as well during that period of time saying something needs to be done quickly. We can't have poor quality cables in buildings. In fact, in particular, under the construction products regulations, we now have to have a certification on all cables that go in, and they just said, if we're going to have a certification, could we have it to a little bit of higher standard, or let's lift the level a little bit over a period of time. So there was a lot of discussion about it, and in the end, we have settled on the Class DCA as being the standard that we should go to. The problems arise here when fire officers go into a building, let's say Grenfell, and Grenfell actually was one of the particular issues that put an urgency on this. When they go into a building, the wiring tends to have been installed above the ceiling in the main escape routes. So the added danger is that several hours after the fire has been burning, maybe everyone has left the building, but the fire officers are in the building searching for people. And the corridors that they're going down have cables, I suppose, firstly falling down out of the ceiling because the cable containment may not be sufficient for them. But secondly, the cables apparently were giving off a lot of smoke and also dropping acidic material down on top of the fire officers. Some of the PVC covered cables that we have been installing for years on end, when they're burning, give off an acid. So there was a move towards selecting a class in accordance with EN 50575, and the classes in that standard are listed on the left-hand side. They run from what I believe is Class A, which people tell me is not really available, to B, C, D, and right down to F. The standard that we have selected for Ireland that is now put into the proposed new regulations is level D, which we believe is not on the bottom. It's pretty close to the bottom, but part of the discussion resolved also around whether this standard should apply to public buildings or whether it should apply to domestic houses. And then we got back into a debate which went on for several hours about what's a public building and what's a private house. Is a bed and breakfast, for instance, does that warrant more safe, a safer cable than an office building? And if you have a domestic house and it's several stories high and you have a lot of people in it, should that have a different standard? So in the end, the committee decided that the new requirement would apply to all buildings, and there would be no differences between the buildings that it would apply to. So that does mean if you're out in an industrial situation, if you're out in a workyard or something like that, or possibly even in a refinery, you might have, if there's materials outside, those cables or cables installed outside, they don't have to comply with those new regulations, but all buildings will be required to comply this class. We are concerned and aware that the industry may take time to buy in these new cables, to manufacture the cables to start with, and to buy them in and get them into Ireland. So we're looking at that in relation to the implementation dates for that particular clause. Having said that, the industry in Ireland at the moment is saying to us they would have time enough to come around to supplying these cables once the new standard comes in. Distribution boards in domestic houses. Domestic houses are unique in that if you install a distribution board in an escape route in a commercial building, you have to put it in behind fire doors. You'll all be aware of that in your commercial installations, but of course your domestic board at home in your own house is just hanging probably down at the main board, at the main door, at the main exit route out of the house. So there's a need to improve on this. In the UK they improved on it several years ago, and they introduced the rule about non-combustible material for domestic boards. In Ireland we have now moved down that road as well. So this will apply in domestic installations where you have the distribution board in the corridor. You are now required to have it manufactured of non-combustible material. RCDs. We've been installing RCDs for years. When they were new, there was all new and exciting stuff to us. There were a lot of tripping and a lot of faults reported on it. Part of that could have been to do with the way we were installing them. Maybe the selection of circuits and things like that was poor. But over the period since 2008, the last version of the wiring rules came out, RCDs have settled down. However, changes have occurred which have now shown us that the type AC that we traditionally install can in fact be blocked by DC currents that have been superimposed by various bits of electronic equipment that we've installed in our buildings. And that phenomenon is in fact increasing rather than decreasing. So you can see from the chart on the right hand side, I borrowed that out of the UK's 18th edition, but it's just an explanatory chart of the different types. We have type AC, which we've been using for years on end most commonly. Type A, AKV, F, B and EV. The big problem with the type AC that we can see in the chart there is that if we have this little DC pulse superimposed on it, then the type AC RCD may not actually trip if it had a residual current fault. It just wouldn't see it, would be blinded. So the newer types, type A, type F and type B, can overcome this. The different types suit different types of installations. Sometimes you will get electronic equipment. Some manufacturers are now printing on the equipment that you may buy that the circuit is required to be protected by a particular type, a particular label, A, B or F RCD. So the proposal is that in this case we will ban the use of type AC since they're susceptible to being blinded. We'll ban them in all new installations. That's not for existing installations, but I suppose as designers such as yourselves, when you're out there looking at existing installations, there is a bit of an onus on you to look, particularly if it's old and if it's a risky installation, or if there are people at risk in that installation. There's probably an onus on you to look and suggest to the client that at some stage further down the road, the old AC type, which might be blinded, might need to be replaced. But for the moment, the ruling will apply to new installations only. Just to keep ahead of time, this is surge protection devices. There's an entire section on surge protection devices which gives a lot of drawings, a lot of details, a lot of diagrams on how to install them, where to put them in your network schematic. I won't delve into that at this time. We'll be short of time to do that. Model certificates. We've always had model certificates in the back of the standard. ET 101-2008 has them in the back. But under our new regime, CRU oversees the inspection and verification process. It's not a function of NSAI, and therefore it doesn't really fit into the standard. So the idea is that the new standard won't have the model certificates in the back of it. It will just have to say that periodic inspection and verification is required, and initial verification and inspection is required. But it doesn't give you a model certificate. There's a second reason for doing this, is that RECCE themselves are responsible now for producing the certificates, and there have been changes in the certificates to date which probably aren't reflected in the ET 101 that we have out there at the moment, but also the number of changes will probably increase over a period of time as they move towards an online format for issuing completion certificates. So therefore there are no model certificates in the new standard. They can be got directly from RECCE Safe Electric. Special locations, what changes have happened there? There are probably too many to mention in that, but the biggest one, which you may have come across already, is Part 722, charging for electric vehicles. This is a growing electrical area right across Europe, and we have previously issued this as an appendix to the existing ET 101. It exists also in the new IS10101 without change. Part 8 is a very big change for designers. Well, I suppose the important thing to talk about it, or to look at it, is that it primarily includes recommendations and guidelines on optimizing energy efficiency in an installation. Europe is very concerned, obviously, about carbon emissions right across Europe, across buildings in particular, and as part of that, they would prefer that there was better analysis done at the design stage of an installation, which might avoid I-squared-R losses in copper cables. If you have longer runs of copper cables, or you've installed your primary supply at a distance from where your installation is. So in order to overcome this, these smaller losses add up right across the whole of Europe. In order to overcome this, they're asking you to look, and only recommending, they're asking you to look at this at the design stage, because of course the shape of the building and the layout of the distribution boards and the primary incomers, that's what will affect this in a big way. It's too late once the building has already been designed and this stuff is being installed. So included in the recommendations is that, number one, you would know the key electrical loads, you'd calculate copper losses, and that you'd size cables suitably or move the load centre. In terms of sizing cables suitably, they look and say you've got to consider the idea that if you increase the size of cables, and we all as consultants love doing that, we're regularly accused of oversizing cables, but they do ask you to consider that oversizing a cable may have a capital cost at this stage, but over the life of the cable installation, that capital cost may actually be minimised. It may be very small compared to the running cost, the I²R losses that you'd have if you reduce the size of the cable. So they're asking you to look at that. They're also asking you to look at the idea that a prosumer, which is a consumer that produces electricity and sells it onto the grid or produces it for their own use and also consumes electricity, they may require different things. They may require, for instance, a time of day control, so that at certain times of the day, if they've got solar panels on the roof or if there are wind turbines there contributing, or a CHP, that certain loads may want to be switched in or switched out depending on where their energy source is, and that could be coming from either the national grid or an alternative supplier or from their own generated electricity. So they're asking you to consider that when you design your distribution boards and your centres and your cables throughout a building, that effectively this will look to allow the prosumer produce at an optimal time of the day or an optimal tariff price. And then equally they'll ask you to look at monitoring and metering, which is something you probably do already on most new installations, to make sure that there is sufficient metering there so that the client can have the information they need to make choices about switching on and off loads. And they also mentioned the concept of several alternative suppliers. We spoke about that earlier. The prosumer might actually be producing some of his own energy as well as buying it in off the grid. This will become a bigger issue when we start using electric vehicles, because electric vehicles may benefit from being able to use solar power. It might be a good idea to charge your electric vehicle only when you have solar power available or when you have a wind turbine running, whereas switch off that EV charging at other times. The key items, I suppose, on Chapter 8 is, it says the scope introduces recommendations for the design of installation. So they're not actually mandatory, they're only recommendations. And then the other part, which is very important, is in Part 4 of Chapter 8. It says the requirements and recommendations of this part shall not impair the requirements in other parts. In other words, the safety requirements of the national standard are more important than the energy. These parts are only a recommendation and things to be considered. Chapter 8 includes a huge number of tables where you can describe the areas and the types of loads that you have in the building and prioritise loads. There's tables and tables of it in there. It's great stuff for designers to spend of an evening reading, but we don't have enough time to go through it here. So in summary, the items that are new in the standard are residual current devices on domestic premises, on lighting circuits on domestic premises, arc fault detection devices recommended. EMC directive, we've got to sign compliance with that. Cables to be rated class DCA. Distribution boards in domestic installations to be non-combustible. RCDs type AC are not recommended anymore. Model certificates have been removed from the standard, and the energy efficiency part 8. Dates, what happens next? The document is currently out. IS10101 is out for public consultation on the NSAI website. You can log in and you can download a copy of it, and then you can pass any comments you like. Unfortunately, comments do have to be received in the format that NSAI has specified. If you just send in an email, your comment won't be picked up. But the purpose of having a public consultation phase like this is that you guys in the industry can make your comment and can influence, if there are particular rules that you have an interest in, you can influence the direction that this goes before the document gets published. After public consultation, we'll move towards a publication date. And the publishing date really will be probably around April or May. The publishing date really be when the book goes on the shelf and you can buy the book, but it's not actually implemented at that stage. It'll give you time to have a look at the book and to plan for future installations. The implementation date, when it's agreed later on, will be the date from which all new designs will then have to comply the IS10101. The certification date will be a question, because there are some projects that you will already have designed and that may be out there under construction but won't finish probably for several years. So how we implement that is still at draft stage, and if you've got comments you'd like to make on that, we would be very pleased to let you submit them through the NSAI website. And also we need to watch refurbishments, because you've all worked on buildings where a particular amount of refurbishment may happen. Maybe 90% of the building gets refurbished, but because it's not a new installation, the client doesn't see why all the wiring should comply with the new standard. So that's something that we will have to consider, and we'd be interested in getting input from you guys on that as well. I have with me here Stuart Hickey from NSAI, and he'll have a quick chat with you about implementation dates and the next moves for the standards just in a minute. But we've had a quick look at those. At this point, what I'd like to do is introduce John Clare from Safe Electric, who is Vice Chair of TC2. And he'll have a talk with you about some particular issues that arise when recce certification, recce inspections take place on site. Thanks, John.
Thanks, Charles, and thanks to IET. My colleague Tim O'Connor setting up here in the back, building inspector from Galway, and also well supported here by inspectors John Connor from Cork and Seamus Green from Donegal. So what I just want to briefly talk about, and it will be very brief, is periodic inspection and testing. There are a few changes here. I suppose periodic inspection and testing was based on the current edition of the National Wiring Rules, and it still is until the new book comes in force. So you were comparing an installation to the current wiring rules, which you couldn't comply with. So obviously there were a lot of issues then to be raised that were non-compliance with the current standard, not necessarily breaches of any particular rules at the time of install. So I suppose the bottom line is that those were generally given as code 4s and were not required to be corrected by and large, but you were informing the customer of these requirements. And in some cases the customer, became maybe not agitated but concerned that there was a list of items on a report that they weren't expected to correct. So the new report is slightly different in that it's an electrical installation condition report, and in this, the change here is that you are asked to give the condition of the installation that you see before you, and to note the condition of that installation. Okay, so we are working on, this is a draft, and again your comments will be welcome, on a new report form. This again is taken from the HD, and we expect to adapt it slightly from that HD document. And again, I suppose without going through each question, it asks the usual questions of the electrical installation, details of the client, person ordering the report, the reason for producing this report, section C, details of the installation, which is the subject of the report, domestic, commercial, industrial, other. So there are a number of tick boxes, and I suppose we're going to try and introduce more tick boxes rather than having to make a comment, which is difficult when you're out on site, having to write down something compared to ticking a box which covers the same thing really. So we'll try and put the words there for you and allow you just to tick a box to comply. Extended limitations of the inspection testing, again that's not new, but it must be covered. The agreed limitations, including the reasons for those limitations, which again is very important to be agreed with the customer. Again, summary of the condition of the installation, and I suppose that's the key to this. It's a summary of the condition. You're not basing the report now on the national rules for electrical installations, you're basing it on its present condition. And you again give an overall assessment of satisfactory or unsatisfactory depending on what you find in the installation. We have a declaration, we have recommendations, we have declaration, sign off, and the report authorised for issue by, again, name, signature, registered number, address and date. Okay, again, some of the detail, and bear in mind this is still in draft form, we're going to I suppose, tidy this up, but again it asks the relevant questions of the installation, earthing arrangements, a number of type of live conductors, nature of supply, means of earthing, main protective conductors. So again, it's a comprehensive, if you like, questionnaire on the condition of the installation you have before you. Again, main switch, location, type, number of poles, current rating, voltage rating, and so on. So again, I'm not going to go through everything in detail here, but that's, if you like, a glimpse of what we propose to be the new form, which is slightly different to what you're used to. We may have to look at altering the form to suit different requirements, and we can do that now. As Charles said, the fact the form is not in IS101 means we can make slight changes to it without having to go through a difficult process in making an amendment to the rules. So I suppose the key to any periodic inspection report is the observations at the last page of the report. You give it a reference, you give the detail of the issue that you find, the breach of the rules, and your classification code is given over to the right, and that is critical. So we have 3 different categories. We had 4 in the past. The 3 are C1, danger present, risk of injury, and immediate remedial action is required in that if you give it a C1. C2 is potential danger, and urgent remedial action is required in that case. C3 then, improvement required, and does not necessarily mean the report is unsatisfactory. So that would be something that you could recommend to the customer to be done, but it doesn't mean that the report becomes unsatisfactory. So this is what we propose then as a tick sheet. So we take, just take the meter tail there, for example. It will be either satisfactory, not applicable, it's hard to see where it would be not applicable, outside the limitations, and at that point then you give a C3, which is improvement recommended, and that still remains a satisfactory report. Where we go to the next line then, where we have unsatisfactory, and we give a C1 or C2 depending on the severity of the issues found. So that's the makeup of what we propose to be the new report form. And again, as I say, feedback is welcome on that. It's at early draft stage, but we hope something on those lines will be used. The code that's missing here is code 4, and in the old periodic inspection, the existing one I suppose is still valid. Code 4 said it didn't comply with the current national rules for electrical installations, and that's the difference. We're not asking for that anymore, and I think that's a good thing. Because if the customer's not going to be asked to fix it, then why risk upsetting them with a list of issues that they're not going to deal with. Now, if a customer comes to you and says, look, I'd like to bring my installation up to current standards, that's different. Then you can list them because they want them addressed. That's a different scenario. Okay, so that's the existing code 4. Okay, the codes, you're probably familiar with the way they work, but just briefly, code 1 is an immediate, what we call immediate hazard, and that's, if you like, a red code, a very serious issue. It must be dealt with immediately. So that's a code 1. There are not that many code 1s out there. It's an immediate hazard. Somebody is likely to be killed or badly injured at this time if action is not taken. Code 2 then is potential, and that's a different animal. I suppose, we have arguments with this all the time, but that could be where an earthing conductor is broken or not present at all. And so you could have an outlet that is unearthed, which is a serious issue, but it is a potential hazard. There is no hazard there, right there and then, unless something else happens and something else goes wrong, and then it becomes immediate. So a broken air, for example, is a potential hazard, even though you might say, well, that's very serious, I wouldn't accept that. It's not an immediate hazard. You just need to find the difference. The codes themselves are not critical. The critical thing is that if you have a broken earth, that you find it and you report it. The codes, we can argue over the codes, as long as you find the issue. That's the main thing with a periodic inspection. And then quote 3, improvement recommended. So that's the lesser of the 3, obviously. Okay, I just wanted to talk to you briefly about isolation. It's something that has come up time and time again and creates problems in industry. And where we have issues in industry are where we are out on site, a contractor hasn't complied with the rules, but there's a very good reason for it. And we have a dilemma then in that this issue is clearly in breach of the rules, yet to be fair to the contractor, we feel we can't breach the contractor. But if we don't breach the contractor, we're not doing our job, and obviously that's not ideal. So where we find a rule that in some cases is not workable, we would like to see a change so that the contractor can comply in every case with it. So I suppose the next couple of slides I'm really looking for your input in that, isolation is a big issue in any installation. Is it accessible? Is it clearly labelled and marked to anybody that might need to use it? And is it within 2 meters of the main supply point? And again, I think you'll find in a lot of cases, you as designers in some cases will be designing installations where the main isolator cannot be within 2 meters of the main supply point. And in that case, we might need to look at that. So that might be something you might need to feed back into the system with if you feel, that you've seen installations, you've designed them, and you can't comply with that. Why? Because there might be a glass front to the building where the supply comes in, and the supply is moved away 2 meters from the main entrance, which is the ESB requirement. It must be within 2 meters of the entrance. And the main isolator is within 2 meters of that, which moves you away. So, you could find that it's difficult to comply with that. So just, I suppose your feedback would be welcome on that. If you feel it's a problem, or if you feel that you can comply, we would find that there are installations where it's not possible to comply with that, and we were looking at maybe saying as close as practicable to the supply point might be a better requirement there. Okay, that's 462 covers isolation for single supplies to buildings. 539 covers multiples, where you have more than one supply to a building. And again, I raise this because it creates difficulty in, certainly for the inspectors and I think for the contractors out there, where how do you comply with this? And we have had difficulties from some engineers trying to design an installation and yet comply with this. So again, I suppose we're really throwing this up and asking you that if you have difficulty with this, to feedback to NSAI and make your comments to 539, which is pretty much a homegrown set of regulations, and we feel that it needs tweaking, it needs tidying up, and we would like you to help us with that if you like, because ultimately you as designers, it starts with you. So if you design an installation, the contractor wires it, we come out and inspect it, and it doesn't comply, we ought to have a problem then. So if we can alleviate that problem, that would be very helpful. We did have, I suppose, an issue with D. A switch room located within the main building should have at least one external wall containing a door providing easy access directly from outdoors. And when I was young, I came from a rural background. Outdoors meant outside, up the fields, into the woods, wherever, that was outdoors. All of a sudden, nobody seems to know the definition of outdoors and what exactly that means. And can you have a roof over you and still be outdoors? So it does create problems. And again, we'd like them resolved so that we can, I suppose, all be clear on what's required. So again, your feedback would be welcome on that. Thank you for that. I'll hand it over to Charles.
Hello everybody, I hope you're having a nice evening. My name is Stuart Hickey, I'm a Standards Officer with NSAI and Technical Secretary of TC2. Now, I intended to give everyone an overview of the IS101 development process, but Charles has covered everything very well in his presentation, so I should really get Charles to present for people before me in future. But just to reiterate some of the key points. Here's a photograph, a recent photograph taken of Technical Committee 2. As you can see, the members, all of you are familiar with AECI, ACEI, EMDA, NECI and ECA, representing the interests of our members. Here's the front cover of IS10101. It's a very lengthy document, about 680 pages in length. Now it's important to note that TC2 didn't start off with a white page and develop all the content from scratch. So Irish experts collaborated with experts from over 50 different countries around the world to develop the content, the technical content that you'll find in this draft document. We had a lead delegate, John Clare, who we had up there a minute ago, represented Ireland at Senelec TC64 last year in Prague. And here's the slide which I want to reinforce some of the key dates. So the development process for IS10101 started nearly over 2 years ago. So a task force was assembled under Technical Committee 2, which comprised of technical committee members and also experts from the industry. So the task force, first of all, started meeting on a monthly basis, then it became a fortnightly basis, and towards the latter end of last year, it was probably a weekly basis. So literally thousands of hours of voluntary time has gone into the technical review and development of the draft document that you have all seen. This is time, voluntary time by our members, time away from families, time away from other things, extracurricular activities that they might enjoy doing. So I think it's worth we acknowledge the experts for their contribution in that regard. So the task force hit its first key milestone in October of 2018, where it finalised a draft for Technical Committee 2's approval. Once approved by Technical Committee 2, the document was escalated to the ETC. The ETC is the Electrotechnical Committee, which oversees all our technical committees, including TC2. And it provides governance and oversight in our electrotechnical domain. Once approved by the ETC, it was also approved in parallel by the NSAI board. It went out for public consultation then on the 3rd of December last year. Now this consultation period is the maximum permissible period we can give you, which is 3 months. And just to guide you through, step by step, how you can provide feedback on the standard. So feedback will only be accepted through the formal NSAI Your Standards, Your Say platform. Now the simplest way of finding this is to log on to the NSAI website. You can also Google NSAI Your Standards, Your Say. Now in the center of the slides there, you have search by keyword. So if we enter in 10101, it will bring you to this page here, which provides draft details on the standard. So you must be registered, a registered user, so you supply your name, your email address, and then you can read the draft. You see the button over on the right hand side. You can alert colleagues. If you scroll down the page a little, you'll come to the commenting section. Now you can comment, you can make general comments on the document, on the whole document itself. You can make technical comments, you can make editorial comments. You can make any type of comments you wish. So what happens when the comments come back to us? We get back to our timeline. So all the comments The end of the deadline for the comments is the 28th of February. So we have another 3 weeks. Once all the comments are received by NSAI, they'll all be compiled in a single document, and the TC2 task force, who had their first Christmas holiday there in 2 years, will get busy again in the following months. Once the comments are addressed, and of course we'll have to go down through the document comment by comment and try to add value to the document where possible and revise it where possible. Milestone 4, the final publication. Now that's likely going to be May or June of 2019, this year. Now Charles already mentioned this isn't the implementation date, it's the publication date. Post-publication, we plan to run a series of technical seminars in conjunction with Safe Electric around the country, so there'll be plenty more evenings like this. And our milestone 5 there is our implementation date. Now, ultimately, this is a decision for the Commission of Regulation and Utilities, but they have indicated to us that a 6-month period is likely to be the implementation date, post the publication of the standard. So those are just the key dates I wanted to reinforce. I want to thank you all, first of all, for turning up. I want to thank Chris and everyone at IET for hosting us tonight. Chris sits on our Electrotechnical Committee, which is the oversight committee I mentioned there.